Once again, your home plate for tonight is only one function, but they are asking you to do 4 different transformations. Today we're going to cover some of that. But today I'm introducing the last part of the transformation formula. Okay? So, our objective for today, I can transform a function using different parameters. Once again, I can transform a function using different parameters. We don't need a fair model. I want us to get started right away. But by now, you should know that functions are relations with exactly one output for every input. Jordan, focus. Examples, non-examples. Last week, we left off with this, yes? Yes. And we understood that there were 3 different variables with 3 different components each. We went into decimals, we did some exploration, you answered the questions, yes? Yes. Alright, next. Today, I'm introducing, if you notice in front of you, we have g of x equals f of 1/2 x. So we're going to be looking at fractions now in our transformations, okay? So, in your Cornell notes, not on the graph paper. Once again, in your Cornell notes, not on the graph paper. I want you to copy that graph including the function. You're like, what do you mean, Mr. Q? Yes, make your coordinate plane, the domain from -4 to 4 and the range from -9 to 9, and copy that function. And don't use the little graphs that you got from your Gopher, because those are not going to show you all the points the way I want you to see them. So make sure you make your own. I'll give you some time. Ready? Go. Copy and go. Okay, we good up to right there? Alright, so first things first, it says the graph of f of x equals x cubed is shown. Here it is. And by now you know what a cubic function looks like. There it is. Oh, I'm sorry. There it is. Alright, so there it is. And now they want us to graph g of x equals f of 1/2 x. So, what is the first thing I asked you guys to do when we first started transformation? Make an input-output table of the points they give you with the original function. So let's do that. I'm going to do x, f of x. My first point here is -2, what? -8. -2, -8. Next point, -1, -1. Next one right here is the point of origin, 0, 0. Next one is 1, 1. And the last one is 2, 8. Oh, sorry. Okay. However, now they want us to do this transformation. So, write your utensils down, look up to the screen. I'm going to go ahead and do the transformation here on the side. So like that, it's close by the table so you guys can see exactly what we're going to do with it. Here we go. First of all, reminder, what is the overall rule that we're using? To the 3rd power. Whatever it is that we're going to do to f, and then work to the 3rd power. Okay? So, this is telling me that I'm going to take f of 1/2 x. Let me zoom in. What does it say again? F of 1/2 x. So where's x? Right here. So this is saying to do what? 1/2 times what? To -2. That is correct, because that's x. So this becomes what? -2 over 2, which is -1. Are we done? No. What's the overall rule? To the 3rd power, so this is -1, because -1 times -1 times -1 is -1. Yeah, any function to the odd power, and if it's a negative, it remains a negative. Okay? All right, let's do the next one. What's my next x value? -1. So that means 1/2 times -1. So that gives us what? -1. 1/2. Am I done? No, the rule is what? To the third. Once again, I'm going to go part by part. First, the numerator. What is negative 1 to the third power? Negative 1. Once again, I said I'm going to start with the numerator. What is negative 1 to the third power? Okay, is everybody seeing it? Okay, well, let me take you back to algebra. Here we go. If I put a 1 here, I distribute that. That becomes what? Negative 1 to the third power. What is negative 1 to the third power? Negative 1. I put a 1 here, distribute that. What is 2 to the third power? Very good. 8. 2 times 2 times 2. Alright, and 0, 0. And fill in the last 2, please. Okay, you should have gotten 1/8 and 1. Hands, have you got that? Okay, let's graph that. Plot our points. My first point here is negative 2, negative 1. Negative 2, negative 1 is right there. What's my next one? Negative 1 and negative 1/8. So let's see where that's at. Negative 1, negative 1/8 is very close right there. Next, 0, 0. 1 and 1/8. And the last one, 2 and 1. Let me zoom out. So imagine that's your original one. You have your rubber bands already set. What do you do to make it look like that? Talk it over to your neighbor. What do you do to your original one to make it look like that? Alright. Well, let's see. Let's do an exploration. Before we go to Desmos, I'm going to give you another activity. I want you to copy these questions down, please. And copy this general rule that we introduced today. G of x equals f of 1 over bx. And the questions are, what happens to the graph when b is greater than 1? And what happens to the graph when b is in between 0 and 1? Okay? Alright? So, 2 questions I need to answer. This is the general form that was introduced today. Alright? What happens to the graph when b is greater than 1, and what happens to the graph when b is between 0 and 1? Okay? I'll leave that up there. Let me forward the screen. Click on it so you can go to the link for Desmos. And the password is UD, as in David, V, space, M as in Mary, B2. There it is again, in case you didn't get it. It's up on the screen. UDV space MB2. Go ahead and log in, and I'll wait for you really quick. Does it? It's up on top. UDV MB2. Okay? So, this is what you're looking at when you log in. Look up, please. So, I'm going to take you back in time once we finish with our algebra review, and I said, okay guys, first things first. Do you remember how to graph x squared? G of x, or f, we had f of x equals x squared. Yes, and I said, everybody graph it, right? And I said, today we're going to do our first transformation. And I said, write this down. Let's go to the second slide. Everybody go to the second slide. And that's when we introduce k. You guys remember that? All right? So, before we move on, tell you never what k does to any function. What does k do to any function? Everyone, it goes what? Up or down. That is correct. And if you want to see it, just press play on the little button there, and you'll see it go up and down. There it is. That is correct. All right? Next, I'm going to pause that. Let's go to the third slide. I said, all right, the following day, I said, we're no longer in k. Now I'm going to introduce a new variable, which is h. Tell your neighbor what h does to any function once it's open inside the parentheses. Everyone, what does it do? Left to right or right to left. That is correct. So if you press play here, look what it does. It goes from one side to the other side. Yes, that is correct. All right. Next, the following day I said, well, today, go to the next slide, we're going to combine both of them. You guys remember that? We combine h and we combine k on the same function. And we did two transformations for each function. Is it coming back? Yes? All right. From there, I said, the following day, is everybody ready to kick it up a notch? And then we went to slide 5, go to the 5th slide, and that's when we introduced a. So before we continue, think about it. What happens to the graph when a is greater than 1? And tell your neighbor what happens. What happens when a is greater than 1? Everyone, what would be one word that happens? It stretches. Yes, it becomes narrow. It stretches vertically, like this. Like if you're pulling some strings like so. Okay? What happens to the graph, check this out, when a is between 0 and 1? Let me show you. Between 0 and 1. From there to there. Instead of stretching, it becomes what? Compress. It compresses. And everything along the vertical axis. Okay? Next. What happens to the graph, before I move on, look up please, we're still not in 6, we're still in slide 5 guys, some of you went ahead. What happens to the graph when a is less than 0? Think about it, what is less than 0? Tell your neighbor first, what is less than 0? Negatives. Alright, what happens to the graph or to the function when a is less than 0? Everyone. It turns upside down, that is correct, or it reflects about the x-axis. Are we there so far? Alright, so let's move on to 6. And today we introduce g of x equals 1 over bx, and we're going to find out what it does and answer your question. So I want you to move the lever, explore it, answer your question please. Hurry up. 30 seconds. Whoa. So what happens to the graph when b is greater than 1, Jake? It stretches sideways. In other words, it stretches horizontally. That is correct. And Jake, let's go. It stretches horizontally. Okay, go to the next slide. Slide number 7. There you have b between 0 and 1. Slide it. And see what happens to the graph. Answer your question, please. Talk it over to your neighbor, let them know in one word what happens to it between 0 and 1. One word. Alright, let's see. Javier, what happens to it? It narrows down? Oh, okay. So on the previous one, from greater than 1, it stretched. So what is this called? Compresses. Compresses horizontally. That is correct. Okay? And now let's go to the last slide so you can see it completely with the formula. Let's see how it looks. Bam! Let's go!
That's scary.
Alright, I'm going to give you some time to explore, but I want you to start with B first. Move the lever, see what it does to that graph, and then move the others, and see if you agree with what you were thinking about in regards to those. I'll give you some time. Alright. Alright, really quick, look up to the screen. Look up, guys. Here it goes. Let me go full screen on this. So, I said, play with the lever of B. So we said anything greater than than 1, it stretches, yes? B between 0 and 1, it compresses. Okay. However, we haven't answered the question that says, what if B is less than 0? What are we talking about in regards to less than 0? Negative numbers. So if B is a negative number, look what happens. Look up. Let me bring it back again. Here it goes. B greater than 1 stretches. B between 1 and 0 compresses. And B in negatives. Tell your neighbor what happened to it if B is less than 0 or if it's a negative. Did anybody catch it? Let's see, let's ask Kenzie. Kenzie, what happened to it? It stretches the other direction, which is what we call a reflex about the y-axis. It reflects about the y-axis. Yes? Yes, Gio. Alright, go back to Nearpod, please. And write this general formula down. Write it down, please, because we're going to do a transformation right now with all the components and see how we do. Oh, yes. G of x equals A times f of 1 over bx minus h, close parentheses, plus k. And this is going to be your BFF for transformation of functions. Okay? Alright, we got it? Did everybody write it down? Okay, here we go. So, on your graph paper, copy this down, please. Example Super Q, copy that. It says graph, the graph of f of x equals x squared is shown. Graph g of x equals f of x minus 2 plus 3 over 2. Copy that, and I'll go over it as, on the graph paper. And remember, in order for you to graph this parabola, you need an input-output table, yes? Alright? Copy and go. Look up to the screen. So, I gave you guys this general form for transformation, right? Now check this out. I just want to make sure we understand what each piece does now that we have all variables. Here we go. A. It does what? Stretch or compress In which direction? Vertically. That is correct. Next one, B. What does it do? Stretch, compress, horizontally. All right. And of course you know what H does, right?
Yes.
It goes which direction? Left and right. How about K? Okay. So let me ask you a question. If I was to give you a big function, look up please. Which are the easiest ones to transform? H and K, which means we're going to leave these till the end. So what are we going to worry about first? A and B, or stretches and compression. So write a little note for yourself, a heart, aww, and we're going to do this first. Always do stretches and compressions first before you do the moving of the graph. Unite. Okay, we got it?
Yes.
All right. Did that help to see the parts of the formula? Yes? All right. Here we go. So we need to create an input-output table. Here we go. X, f of x. So my points given are -2, 4, -1, 1, 0. Okay, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Okay. But now they want me to use this transformation. You're like, Mr. Q, it looks weird because it has all that divided by 2. All right, then let's rewrite it so it can look similar to something we've done in the past. Let's see. Hold on. What is the individual or the invisible number that goes here? A 1. So do you agree that in front of the whole function we have a what? 1/2. That is correct. We bring everything else down. F of x minus 2 plus 3. And we write g of x equals that. Does that make sense? So now look at it. Bless you. By looking at it, let me move this over this way. By looking at it, do we know what the -2 will do?
Yes.
Yes, it's going to go in which direction?
Right.
No. Right now, in which direction?
Right.
To the right, 2 steps. How about this one? Up 3 steps. So which is the only one that we need to worry about? The 1/2 of f of x. That's the transformation we're going to do first. So I'm going to zoom in over here, and I'm going to add a column here for that portion. I'm going to label it what? 1/2 f of x. Okay, so what is f of x here?
4.
What is 1/2 of 4? 2. Then we have 1. What is half of 1? 1/2. 0, 1/2, and 2. All right, let's graph that so you can see at least whether it's stretched or compressed. Let's see. We have -2, 2, -2, 2. There it is. Next one, 1 and -1 and 1/2. -1 and 1/2, which is right there. 0, 0, 1 and 1/2, and 2, 2. So what happened to it, everyone? It compressed. Okay. However, am I done with the transformation? No, now we have to do what? 2 to the right, and then 3 to the... Start with the point of origin first. Here we go. I'm going to zoom in. Yes?
How come we did the 1 and the 2? You go back to the... Yeah, right there. How come?
Because this is the same as this. So we can rewrite it so that it's something that we already saw before. Because this, you haven't seen this style, right? So we can rewrite it like this. Alright, so 2 steps to the right, 1 and 3 to the top. 1, 2, 1, 2, 3. This one, we're at half. 1, 2, 1, 2, 3. This one, 1, 2, 1, 2, 3. And here, and here. And there you go. Tonight's home play is the only problem that you have today. Have a good one, guys. Help me put away the iPads before you leave. Thank you. See you guys tomorrow. There is tutoring today. Bye.